Hello, everybody. Thank you so much for joining us. My name is Dr. Lahnor Powell, and I'm actually usually the moderator for such events. But for today, I will actually be your presenter. So for LiveGDX, it will be brief, but it will be good, I promise. So we're not only hosting members on our traditional GoToWebinar platform, but we also are live on Facebook, we are live on Instagram, and so our audience is diverse, and I really would like to welcome everybody. Thank you for spending just a little bit of your Wednesday with Genova Diagnostics today. So before we get started, there are quite a few housekeeping items that I would like to discuss. So number one, this is not a closed session. So I do ask, please do not type in the comment section any patient-specific information or self-specific clinical information. If you're on the GoToWebinar platform and you have a question, you can just type it into the questions box and the moderator will respond. If you're a healthcare professional on Instagram or on Facebook and you have a question, please email us at LiveGDX@gdx.net, and we will work hard to respond in a timely manner. If you are a patient, we would like to encourage you to go to www.gdx.net/patients with an S/find-a-doctor. And that way you'll be able to locate a healthcare professional in your area that may be familiar with functional testing. So why are we really talking about amino acids today? You know, somewhere in between studying for boards and graduating XYZ years ago and life, the details of amino acids it just becomes a little bit fuzzy. So my goal is to really provide a quick refresher. For today's conversation, breaking down amino acids and keys to interpretation, I will cover three big things. Number one, the 5 factors that influence amino acid levels, discuss a few notable essential, non-essential, and conditionally essential amino acids, and also number 3, a brief review of interpreting intermediary metabolites of your amino acids. You know, there's so much more to know about amino acids beyond what we're going to be discussing today. So if you want to know more information, if you want access to our amino acid support guide, if you're on the GoToWebinar platform, look under documents. You can actually just download it right now. If you're a healthcare professional and you're streaming live on Facebook or on Instagram, go ahead and send us the email requesting this specific document. So again, the email address is livegdx@gdx.net. And if you're a non-healthcare professional or a patient streaming live on Facebook or Instagram, we encourage you to talk to your healthcare professional, or if you're searching for a healthcare professional, you can go to that website that we listed before where you can identify a healthcare professional in your area. Again, let's just kind of dive on in here. Let's lay a little bit of a groundwork about amino acids just to help us better understand what these 5 factors that influence amino acids are. So what are amino acids? And many consider amino acids to be like building blocks, because when you put several amino acids together, you make what's called a protein. A protein is a macronutrient, and it's comprised of 50 to 200 amino acids joined in a variety of different combinations. And these different combinations dictates what's the function of that protein. We usually get protein from our diet, both animal and from plants as well, plus supplementation. So when we eat the protein or consume the protein, we begin to break it down into smaller amino acids by chewing, the acidic environment in our stomach, as well as pancreatic enzymes. And then this process of absorption occurs, where we have in the small intestines these little microvilli or finger-like projections that will help to take those proteins or amino acids and move them into circulation so the body can continue to use them. Let's just imagine your body's ability to digest and absorb dietary proteins is impaired by either not having enough digestive enzymes, or maybe you just don't have enough of protease or trypsin. Maybe you're not chewing your food very well. Maybe your patient has blunted microvilli or malabsorption from, let's say, celiac disease or a surgical procedure like a bypass surgery or weight loss surgery. This is going to result in lower amino acids when you look at testing. This is the first factor that influences our amino acid levels. It's going to be GI tract digestion and absorption. So now we need to consider protein digestibility. So that's how easily your body can either digest your food based on the type of protein, how is it prepared, how is it processed. So for example, plant proteins in their raw state can be more difficult to actually break down compared to cooked plant products. So in this case, you might encourage your patients to either lightly saute or steam their vegetables. Now, in terms of animal products, cooking them at high temperatures, so like boiling them, it can make it more difficult to digest that protein as well. So we might want to change their cooking methodology. Now, when it comes again to protein digestibility, if there's an issue, what you will see upon testing is you're going to see an overall pattern of lower amino acids despite your patient's intake. The composition of amino acids is also important. Different foods have different amino acid combinations. And the key with any diet is really just variety. If the diet is inadequate in a particular essential amino acid, then protein synthesis won't be able to proceed beyond the rate at which that amino acid is available, really. So let's use an example, grains. Grains are a great source of methionine, but they have very little lysine. Alternatively, legumes like your beans are high in lysine, but they're low in methionine, right? So combining grains with legumes or grains with dairy or legumes with seeds can actually help to provide all the essential amino acids in adequate quantities. So with testing, again, if you see somebody's amino acid patterns tend to look or trend low, we need to encourage a more diverse selection of proteins in the diet or mix it up. Dietary protein intake. So adequate intake is essential for your overall health. And contrary to some beliefs, you do get adequate amino acids in a vegetarian or a vegan diet. When you look at the daily or dietary reference intake, or the DRIs, they actually recommend 0.8 grams per kilogram of body weight for protein. So this means that the average male who's sedentary should eat about 56 grams of protein per day, and the average female who's sedentary should eat approximately 46 grams of protein per day. So with testing, if you see in a low amino acid pattern, you need to go back and do like a dietary or really evaluate what is the intake for this patient. The fifth component we need to look at is protein demand. So there are some instances where your demand for protein actually increases. So let's use, for an example, pregnancy. You have an increased demand for protein of 10 grams daily if you are pregnant. Lactation, breastfeeding, your demand increases by 15 grams daily. And if you're an athlete, your protein demand can increase twofold above the average sedentary individual. So with testing, again, you're going to see this low trending amino acid pattern, and you should always ask, patient, what's your activity level? Patient, are you pregnant or are you breastfeeding? So to recap, again, if you see low amino acids upon testing, think about the following concepts. Number one, GI tract digestion absorption. Do you have GI symptoms or a prior surgery that may indicate maldigestion or malabsorption? Number two, protein digestibility. How are you preparing? How are you cooking your proteins? Number three, amino acid composition. So are you eating a variety of protein sources? Number four, protein intake. Are you getting adequate protein in your diet? And number five, protein demand. So what is your activity level, or are you in some kind of an increased state of utilization for your amino acids like breastfeeding or pregnancy? But what if you have high amino acids, robust amino acids, elevated amino acids upon testing? What does that really indicate? Well, this can be seen in patients who are already using amino acid supplementation, or it can be seen in patients who have a need for cofactors like your B vitamins to actually use the amino acids more effectively versus simply accumulating them. So let's actually talk about a few notable essential amino acids. We're going to talk about your branched chain amino acids, which are isoleucine, leucine, and valine. We're going to talk about phenylalanine, methionine, and tryptophan as well. Now, what does an essential amino acid really mean? So it means that the body is not able to make it. So all essential amino acids you have to get in through your diet. So starting off with your branched chain amino acids like isoleucine, leucine, and valine. Unlike most amino acids, the initial step of branched chain amino acid metabolism, it doesn't take place in the liver. Actually, it mainly starts in skeletal muscles. The branched chain amino acids, they are substrates for protein synthesis, and they estimate that it can account for about 50% of muscle protein and have many other metabolic functions, including energy production, glucose metabolism, and immune response. When you have low levels of your branched chain amino acids, we might want to consider supplementing with things like zinc, B3, B6. It has been shown to improve outcomes in various conditions in which we have low branched chain amino acids. With high levels, with the breakdown of branched chain amino acids, you need several cofactors, things like vitamin B6, B1, even alpha lipoic acid. And so if you are deficient in those nutrients, then we can see a higher trending pattern for the branched chain amino acids, and we might want to replace those nutrients. For phenylalanine, it's found in most foods which contain proteins like your meat, your fish, your lentils, vegetables, dairy as well. And it's the precursor to another amino acid, tyrosine. Because tyrosine is needed to form several neurotransmitters like norepinephrine, epinephrine, and dopamine, as well as your thyroid hormone and melanin for skin pigment, phenylalanine is actually quite important. When you have lower levels, other than the 5 factors we talked about earlier, B3 deficiency, that has also been associated with low levels of several amino acids, including phenylalanine. So for high levels, you have to look at, outside of supplementation, things we already talked about. I'm really curious about artificial sweeteners. Some of them actually contain phenylalanine, like NutraSweet or Equal, and that, again, will result in a higher level if you're taking it through those artificial sweeteners. Methionine, it's obtained from eggs, fish, meats, Brazil nuts, other plant seeds, and also it can be obtained from homocysteine remethylation. So it does play an important role in your methylation cycle. And methionine is converted to the body's main methyl donor, which people call SAM, and that stands for S-adenosyl methionine. So clinically, when you have low levels of methionine, it actually can impact your methylation cycle, given its critical role. That's not good, right? B12, folate, those are needed for to remethylate homocysteine into methionine. So if you have a functional need for those cofactors, it can also contribute to a low methionine level. Lastly, vitamin B3, that's another really important nutrient when it comes to methylation and methionine as well. So when you have high levels of methionine, it could be genetic polymorphisms. It could be problems with like your transsulfuration enzymes, or it could just be you don't have enough of the right vitamin and mineral cofactors like magnesium, potassium, B6, which also alters your methionine metabolism as well. So molybdenum actually is a cofactor for methionine breakdown or degradation or catabolism. So if you don't have enough molybdenum, then you can also have a higher level of methionine. The next amino acid is tryptophan. So food sources are like, turkey, everybody knows about turkey and tryptophan, but also chicken, oats, nuts, and seeds. And it's involved in your serotonin pathway, which people refer to as like your happy hormone that impacts mood. And that's done through a B6 dependent pathway. And then serotonin can be further metabolized to melatonin via methylation as well. Now, when you have low levels, Clinically, it's been shown to correlate with like depressive symptoms, cognitive impairment, but because some dietary tryptophan is converted into niacin, active B3, basically, if you have a diet deficient in B3, you might also have issues with tryptophan as well, those tryptophan levels. With high levels of tryptophan, we see it clinically in those who tend to be more stressed out, have insulin resistance, that have magnesium or B6 deficiencies or are older in age. And a lack of those nutrient cofactors, the B6, the riboflavin, the iron, that can actually also cause you to have higher levels of tryptophan as well. So now let's move into some non-essential amino acids. So the ones we're going to talk about are cysteine, glutamine, and tyrosine. Non-essential means that our bodies can produce the amino acid, right? Conditionally essential amino acids, those are usually not essential except when you are in a time of illness or you are dealing with stress. So again, first starting off with cysteine, it's a non-essential sulfur amino acid, and you can get it from poultry, eggs, beef, whole grains. It's also endogenously made, meaning that your body can actually make it from cystathionine. So cysteine can be used to not only make glutathione, which is like a totally awesome antioxidant, but cysteine is actually considered to be a limiting amino acid in that pathway to make glutathione. But it can also convert into taurine, another amino acid, or it can be used in mitochondria for energy ATP production as well. With low levels of cysteine, it could be a B6 deficiency, which is a cofactor. High levels, it could come from NAC or supplementation with N-acetylcysteine. Maybe you don't have enough molybdenum, which is an important breakdown cofactor of cysteine, or it could be deficiency in zinc or B12, which deals with the whole methylation cycle and how we process cysteine as well. When it comes to glutamine, this is what we call the most abundant amino acid in the body, and it's considered to be conditionally essential, especially for those ill or sick patients. So it's far from glutamate or glutamic acid, which is a non-essential amino acid, and the glutamic acid plays a role for brain development, learning, memory as well. But for glutamine, although glucose is used by many tissues as like fuel or energy, in certain cells, glutamine is used for energy. And that includes your immune cells, like your lymphocytes, neutrophils, macrophages, as well as your enterocytes, or the cells of your intestinal lining. Glutamine is also important for gluconeogenesis, or the production of glucose, immune function, muscle growth, ATP production, just to name a few things. So when you have low levels of glutamine, it could be that you have this higher metabolic demand for the glutamine, or higher levels of glutamine could be a deficiency in cofactors like NADPH, as well as vitamin B1 and minerals. The next one we're going to talk about is tyrosine. So that's a conditionally essential amino acid. We find it in dairy, beans, whole grains, meats, and nuts, but it also can be formed from the essential amino acid phenylalanine. Now, tyrosine is a precursor to several neurotransmitters like dopamine, norepinephrine, epinephrine. It's also needed to create thyroid hormone and melanin or skin pigments. When you have low levels of tyrosine, we think about B3 deficiencies, which have been associated with other amino acids being on the low side as well. But with high levels, it could be deficiency in a lot of cofactors that help make neurotransmitters and thyroid hormone, like B1, B6, BH4, which is tetrahydrobiopterin, copper, vitamin C, among others. So let's just recap really fast what we've been discussing. In general, amino acids are needed to make energy. They're needed to make other proteins. We need it to make antioxidants to help with mood, immune balance, and to support methylation. Do you now see why it's so important to measure patients' amino acid status? Slight imbalances can really impact so many things within the body. So the last topic we're going to cover is going to be the intermediary metabolites of amino acids, and we're just going to talk a little bit about how do we really interpret them, what can they help us to synthesize about our patients. So intermediary metabolites are just byproducts of amino acid metabolism. So you have your B vitamin markers. So we're looking at a few of those markers that specifically require B vitamins as a cofactor for that enzymatic reaction. So elevations can signify a functional need for that specific B vitamin cofactor. When it comes to the urea cycle markers, these byproducts are associated with nitrogen detoxification, and this pathway will take place in your liver. And again, it helps you to detoxify that nitrogen or ammonia into a non-toxic urea that we can excrete out. The most common source of nitrogen or ammonia, it's really going to come from the breakdown of protein, but it can also come from gut bacteria as well. And when you have these elevations in any of the metabolites, it basically signifies a need for specific cofactors for your urea cycle, which are B1, B6, and magnesium as well. For the glycine serine metabolites, they are actually involved in making choline, which can be used for acetylcholine synthesis or to support our methylation pathways. So again, an imbalance here in these amino acids or metabolites may hint methylation troubles, which can be supported by the use of B vitamins, magnesium, and zinc as well. The dietary peptide-related markers, they indicate incomplete protein breakdown and will often lead to digestive support recommendations, in which we can follow up with a GI stool test. So something that you guys might not know about me, I come from a family of professors, school owners, principals, therefore you guys are getting a pop quiz. Okay, so if you want to be bold and answer the questions, you can type it down in the chat or the comment box if you would like. So let me give you a clinical case to start off with. We have a 37-year-old female. Her main chief concerns are fatigue and minor mood changes. She has 2 young children, a 4-year-old and a 14-month-old, of which she still is breastfeeding the 14-month-old 2 to 3 times a day. She also participates in regular exercise. She does spinning and resistance training several times a week. There are minor GI complaints like occasional bloating and abdominal discomfort, but overall, the diet is pretty healthy with occasional snacking. All standard testing like your thyroid and iron were within normal limits. So as a clinician, you decide, let's run a nutrition test to better understand her fatigue and minor mood changes. When you review the profile, what you notice is a low trend of the amino acids. And so you recommend supplementing with amino acids and talk to her, about why they're low in the first place. So here's the question. What are the 3 big factors that we discussed today that can actually contribute to low trending amino acids in this particular patient's case? Do, 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 do. That's my waiting music. I apologize. So let's just talk about it. Number 1, the big factor is this patient is still breastfeeding. So that means that she has a higher demand than a sedentary female for protein, 15 grams more compared to the RDI. Number 2, she's athletic, right? She's doing spinning classes and doing resistance training daily. So this means that her protein demand, depending on the intensity of the exercise, can actually increase by 30, 50 grams or even more. We also said minor GI concerns or complaints, so digestion absorption. So we also want to follow up with the stool test to better evaluate not only digestion, but also absorption as well. Hope you guys got it right. So next, let's imagine you have a patient that you suspect methylation defects, and they potentially have an elevation in homocysteine, which is basically a risk factor for cardiovascular disease and other diseases. It's a blood marker. Here's the question, a little bit different. What markers on amino acid testing would you be particularly interested in to see kind of how you're doing with methylation? All right, so the answer is going to be the glycine serine metabolites. Remember, they're involved in making choline, and choline can be used to support methylation, so you want to make sure that those markers are good. And then also methionine, because the start of methylation is methionine. All right, remember, methionine is the precursor to SAM, which is S-adenosyl methionine, which is your universal methyl donor. So again, hopefully you got that correct. For our last question, it's a little bit different, it's a little bit tricky, but what clinical symptoms would you expect to see with a patient who has an overall trend of high amino acids? So if you have a patient who has a trend of high amino acids, what do you expect to see clinically? Well, this is a tricky one, I'm telling you. And the reason it's tricky is because the same symptoms you see with low amino acids, you can also see with high amino acids. Why is that? Because again, just because you have high amounts of amino acids or robust amino acids, it doesn't mean that you're using them. So clinically, we think about B vitamins, but symptom-wise, those two populations will look the same. They can come in with low energy, with mood imbalances, with oxidative stress, and even poor methylation. All right, awesome, awesome. Hope you guys got 100% on that test. If you didn't, it's okay. Watch the broadcast again. Well, again, I just want to remind everybody, if you are a healthcare professional and you want to request a copy of the amino acid support guide, you want to start a MyGDX account, or if you have any questions, please send an email to LiveGDX@gdx.net. If you're a non-healthcare professional or a patient streaming live on Facebook or Instagram, we would like to encourage you to talk with your healthcare professional, or you can identify one by going to the website www.gdx.net/patients/5-a-doctor to locate someone in your area. I want to thank everybody for tuning in today. I hope you have a wonderful, wonderful day. Thank you.